Hello, this presentation will be focused on the emerging technology of artificial intelligence, specifically machine learning and its usefulness within education. Artificial intelligence can be defined as the ability of a computer-controlled device to mimic human capabilities and mental processes such as reasoning, meaning-making, generalization, and learning from past experiences. In contrast to conventional computing, where the programmer gives the computer precise instructions to follow, with AI, the programmer writes an algorithm that allows the computer to learn to solve a problem by itself. Machine learning is a subset of AI that uses many different examples of data input to adapt and achieve a desired goal. In this process, artificial neural networks, ANNs, inspired by the workings of the biological brain, are able to identify patterns by using a feedback loop to learn from mistakes and improve their results. Some real-world applications of machine learning include automatic language translation, virtual personal assistants, self-driving cars, product recommendations, traffic prediction, and speech and image recognition. The implementation of AI into classroom tasks and activities aligns with multiple learning areas and general capabilities listed under the Australian curriculum. Under digital technologies, the implementation of AI provides context and applications for data and algorithms, as well as relevance to student personal experiences. It is also an industry-relevant area of computer science. The study of ANNs in machine learning additionally provides a strong link to biological science. As machine learning solutions often draw on data from a diverse range of fields, this may provide additional links to a number of other learning areas such as history, geography, media studies, English, and health and physical education. In addition to strong links with the ICT general capability, AI also provides a lens through which to examine the ethical and social impacts of technology and issues arising from the use of AI solutions. This aspect provides strong opportunity for students to develop skills in ethical understanding. This slide provides a number of ideas to incorporate AI and machine learning into teaching and learning within an F-6 primary school setting. The first example, can AI guess your emotion, requires students to provide photo evidence as data input to train a program to recognize different human emotions. The second example, fun projects with language translation, challenges students to create an algorithm implementing a computer program to create a chatbot that responds to input and also translates the output into another language and speaks it. The third example, AI smartphone security, provides an opportunity to investigate security measures, including those powered by AI, that are used to protect users from unauthorized access to their digital devices. This example provides a level of differentiation to cater for students' range of programming skills. All of these lesson ideas were found on the Digital Technologies Hub, which is supported by Education Services Australia and the Australian Government Department of Education, Skills and Employment. The main applications used in the lesson examples so far have been Teachable Machine, as seen on the left, and Studio Scratch on the right. Designed by Google, Teachable Machine is a web-based tool that makes creating machine learning models fast, easy, and accessible to everyone. According to Google, using this application, students are able to train a computer to recognize images, sounds, and poses without writing any machine learning code. Scratch is the world's largest free coding community for kids, designed especially for ages 8 to 16. Using this application, students can program their own interactive stories, games, and animations, and share their creations with others in the online community. According to the Scratch Foundation, Scratch helps young people learn to think creatively, reason systematically, and work collaboratively, which are all essential skills for life in the 21st century. So now the sections model developed by Tony Bates and Gary Poole will be used to assess the technological affordances of Teachable Machine and Studio Scratch. Firstly, looking at ease of use, Teachable Machine requires no prerequisite machine learning knowledge and has only 3 simple steps: 1, gather; 2, train; 3, export. Scratch provides video tutorials, coding cards, and an ideas page, which breaks down the steps of the process, making it more simple. Both of the applications are prone to technological errors, such as crashing, failure to load, incompatible hardware or software, and overload. In terms of cost, both of the applications are free. However, Chromebooks and internet connection are required. Teachable Machine also requires Google Chrome or Macintosh and a webcam, and does not support tablets. In terms of teaching functions, Scratch provides high levels of differentiation for different levels of coding abilities, and both offer task redefinition. In terms of interaction, Scratch, as stated before, allows the sharing of individual projects with class peers and others in the online community. Now, Teachable Machine actually has a safety warning regarding students recording images of themselves or others via the webcam. However, if they close the tab, nothing is saved in their browser or on any servers. And this is certainly an aspect of security and privacy that should be considered. Next, Richard Mayer's principles for multimedia design will be applied to consider the effectiveness of design features within the AI and machine learning applications. Firstly, through Teachable Machine's simplicity of task instruction, the design excludes interesting but irrelevant material to avoid cognitive overload, therefore meeting the coherence principle. Secondly, in Studio Scratch, the use of a color-coded coding system aids the selection and organization of important information, therefore meeting the signaling principle. Lastly, Teachable Machine and Studio Scratch both provide video tutorials, and together with Studio Scratch's coding cards, these design elements meet the pre-training principle by providing an option to view information on key terms to allow learners to familiarize before having to work with them. So in conclusion, when using the SAMR model developed by Dr. Ruben Puentedura to assess the pedagogical use of AI and machine learning applications, such as Teachable Machine and Studio Scratch, each of the lesson examples provided used AI and machine learning to transform teaching and learning at the redefinition level, meaning that they allowed for the creation of new tasks previously inconceivable. That's the end of my presentation. Thank you very much.